So I have the pleasure of the first on-site speaker, uh, Adnan Khan, and let's see. I have to introduce Adnan, but before that, I just have to get his bio. I know you sent me the bio, Adnan. I just have to get it. But I saved it, but so Adnan is the Director of Technology Market Development at Anritsu, and he's part of the CTO group. He's about 20 years of experience, and he is from Texas. I think you got your bachelor's in University of Texas, Austin. And so he'll be talking to us about empowering Open RAN with AI/ML, driving energy efficiency for a sustainable future. He has got 20 years of experience and now part of the CTO group within Anritsu. So with that, let me just share Anritsu slide. All right. So we have the pleasure of the first on-site speaker. It's coming up now. I have to stop sharing this. Let's see. This is it, right? So just for information, we have about 700 people who registered for online. We got about 200 people right now. Is it good? Yeah. All right. Thanks.
All right, good morning and good evening, everybody. So I'm the first on-site speaker over here. Again, my talk is going to be about Open RAN, AI/ML, and how it impacts energy efficiency, right? And I'm a firm believer that what gets measured gets done, and to get something measured, it has to be tested. So I represented a test and measurement company over here. So moving on, quickly, basically, we'll cover off the different, what is the reason for going green? What's the reason for sustainability, right? As well as what are the different metrics by which you can measure the energy efficiency, right? And then looking at how does that apply to Open RAN? And then last but not the least, we'll talk about a little bit about AI/ML and then a summary. But again, thanks IEEE for giving me the opportunity to speak over here and also for giving me the challenge to cover 140 slides in 20 minutes. All right, so let's move on. So pretty much Anritsu, I can confidently say, is older than anybody in this room or online. We got established ourselves about 20 years before Alexander Graham Bell made the first transcontinental call in 1915. So we're established in 1895. We're based out of Japan. We have seen the test of times across all the Gs. Recently, my activity has been a lot on the 6G aspect. So we're developing different test beds around channel sounding, around basically reconfigurable intelligent surfaces, modeling, different coding schemes. So we're looking at all the Gs, including 5G Advanced and whatever 6G is going to be in release 20 and 21. We're about 7,000 employees worldwide with about $1 billion of sales. So without any due respect, I'll move on further on to the next slide. So why do we need to have this greenhouse gas emissions, right? So as part of the Paris Accord, there was a decision made that we have to lower our temperature target, right? And it's not supposed to go up more than 2 degrees Celsius, right, by the time it's in 2050. Right now in 2021, which is 2 years ago, we're at 1.2 degrees already, right? So we really have to move fast and reducing the amount of greenhouse gas emissions and the global climatic changes, right? So that's one of the reasons why is the GHG. Plus, if you look at the different telecom sector, we consume a lot of this energy, right? Roughly the ICT consume about 10% of the global energy that's out there, right? And so key thing over here is what are the factors that we can take into account to be able to reduce the greenhouse gas emissions, right? So not only that, but the governments are involved in this. There is guidance from ITU as well to reduce our emissions and become more carbon neutral, right? And when I say have net zero emissions, that means that the amount of carbon emissions we're doing kind of balances out on the amount of energy savings that we're producing to the environment, right? That's what, in a nutshell, what the carbon neutral and net zero mandate is all about, right? So ideally, in 2022, basically the ICT industry also set a target whereby they're planning on reducing the emissions about half every decade, right? And there are different MNOs across the worldwide. They don't want to wait for the 2050 deadline. They want to look at 2040 and see how much they can reduce their basically emissions by and increase their profitability by increasing the sustainability part, right? So one of the drive is basically the greenhouse gas emissions, but the bigger drive over here across operators is reducing their operating expenses, right? So some of the information I'll be going over may be a little repetitive, but the key thing is the RAN specifically consumes, I would say, roughly about 70% of the operator expenses, the amount of energy that's going into the different cell sites, maintaining them. And even though if you look at it, 5G has been a lot of throughput. It has a lot of features like, at layer 3, you can have connectivity, reducing new RRC states whereby you can go RRC inactive, and then a lot of low transmit time interval to reduce. But the point over there is you have a lot of more data utilization. You may have a lot more small cells over there, right? And you have a lot more wider bandwidth. So all that is consuming a lot of power, right? And that's why if you look at it, what I'm showing you in the chart, again, this is taken from NGMN. It shows the different part of the network, whether it's the RAN, whether it's the core, whether it's the cloud, right? And see how much the consumption has been between 4G and 5G. So as you can see from the edge network perspective, 5G is much lower, or from the core network than 4G, because a lot of virtualization happened on the core. Starting from 4G and 5G is all about virtualization. And that is a key component of Open RAN as well, right? And that's why we see a lot less energy consumption on the 5G part. However, on the RAN part, as I said, we're consuming a lot of more data, and that's where the drive is coming from the operator. Not only greenhouse gas emissions, that is global, but also reduce their operating expenses, right? That's very key, because we have to look at RAN from a perspective of when the RAN is actively transmitting data, there is consumption going on. But also when the RAN is idle, it's not transmitting any data, there's still consumption going on at that time. So that's very key thing, right? And the other part of it, if you look at it, in times of 4G, for instance, or even 5G, there is no mandate right now by anybody, by anybody that you have to measure your KPIs from RAN, how much power you're consuming, right? There's no mandate. So as you go into 6G, that is going to change. Sustainability is going to be a key pivot of 6G pretty much. All right, so as I said, we have to be able to measure things accurately. We have to develop KPIs. So some of the high-level KPIs, you have to look at what's happening on the RAN, what's happening on the core, what's happening between the RAN and the core, and then between the core as well into the cloud or onto the data network where we're providing the application services, right? So you have to be able to measure EE or energy efficiency across the board in isolation as well as end-to-end. That is very key, right? So there are certain parametrics that have been defined pretty much with respect to the energy efficiency. The first one is what we call the mobile network energy efficiency, right? And that is basically the ratio between the performance indicator of how much volume, how much data volume is consumed, and what was the energy consumption to consume that much of data volume. So again, the measurement is mainly bits per joule. So if I'm pumping out, say in a month's time, like 100 of terabytes of data, how much energy is being consumed by one of those sessions? So that's one of the ratio. The other part is in areas like rural areas, whereby we don't have that much data consumption. So we want to look at a metric like from a coverage perspective, like what is the ratio of the area of coverage? So I'm providing a service to a farm or to a village versus what is the energy consumed by the network in that case. That's the second one. And third one is the KPI with respect to latency. And that is basically it's inversely proportional on what the latency is, the user plane latency, and how much energy is being consumed by the mobile network over there, right? So three things, you have energy efficiency of the whole network in a regular area. And then in the rural area, you're looking at more from a coverage perspective. And then if you have more of the LLC applications coming up or the URLLC application, we try to look at what is it compared to the latency that we're achieving in that sort of network, right? And when we talk about the delay is pretty much, the latency is basically going from the handset to the base station, which is over the air interface, and then it goes the backhaul, because there is energy consumption happening between the base station and the link, whether it's a fiber optic link or Ethernet link that goes onto the core. And within the core, there is also energy consumption happening, like I showed on the previous chart, and then it goes on to some application, right? So the end-to-end latency will be accumulative, multiplied by 2 of all of these TR plus TB plus TC plus TT over here that goes over the transport layer. All right, so some of the use cases were already talked about, but I'll just brush over them that have been defined on what are the root cases from the radio access network, as well as some of the core perspective, right? And one of them is what we call switching off the cell, as well as whether you're an inter-rat or inter-rat scenario, whereby you have a cell in the middle, which is a booster in an area, maybe a downtown or so, whereby you do have some sort of bandwidth requirements, high data rate during a certain time of a day. And then when that requirement goes off, then you can switch it off and you can move on to either to a G node B, or even if it's lower, you move on to an E node B, depending what the area is. So basically you can switch cells over here, or you could have solutions whereby you have coverage and you have a small cell that is providing additional coverage, whereby you need from an office space during the daytime, you need higher bandwidth and higher throughput. Then during the nighttime, that specific cell can be switched off and the data can be offloaded to a macro cell from a micro cell, right? So that's the other areas that you can have some cell switching, and that is being discussed in 3GPP as well as in Open RAN, right? Whether you activate energy services, energy savings, which we call ES, and the different mechanisms of activating and deactivating that, right? Secondly, we're looking at what's a lot of stuff is virtualizing, is moving into the cloud. So measuring the energy efficiency in the cloud is very key. And again, this is looking at the different virtual network functions, the cloud native functions, and also looking at different virtualized processes, right? How much energy are those processes consuming? That was not the case in terms of 3G and 4G. So we really have to see how much energy a specific virtualized process or a container function is going to consume on a network, right? And third of all, there are different, again, taken from 3GPP, the different looking at power states that look at the deep sleep, the micro sleep, as well as there is basically looking at, active downlink and active uplink, and the sleeps are pretty much separated right now, depending on what is the transmit time interval, right? So whether are you sleeping on a symbol basis? Are you sleeping on a slot basis? Are you sleeping on a subframe basis? Or you are actually going into a deep sleep whereby your transition time is much longer, right? So the different new power states that have also been defined in 3GPP on how the network is going to enter a sleep state. And similarly, those sleep states are going to be tying to something that we already have in the user equipment, like a handset or so, right? And last but not the least, on the core network side also, there are a lot of functions on the core network, right? If you look at URLLC, for instance, there are talks about duplicating the user plane function. So we're looking mainly on the user plane side. There is redundancy built into the user plane function that you could have multiple UPFs. Some UPF could be closed, providing edge services. So say you don't need those edge services at a certain time of the day. In that case, we turn off that specific UPF that is close to the edge. Because you will have a lot more UPF, you'll have a lot of MEC deployment because of latency sensitive services, and that's going to drive the cost and the consumption of the core network as well. All right. So a little bit about AI ML, as the gentleman before, we talked about the different types of learning techniques, right? You have supervised learning. That is basically you have a model set that is known, it's labeled, and you have a set that is the output, that is also the output set that is also labeled. So you know what you're inputting, you know what to expect. The key thing is what is the algorithm that goes in the middle, right? And that is where I think initially the most of the stuff that's going to be happening on the ORAN side is going to be more favored towards supervised learning, because that takes a little longer. It has longer turnaround times. And then you also have unsupervised learning, right? In that case, you don't have any kind of relationship that is there, right? Between what data you're sending as well as what is the output. So basically it has to be, none of that is labeled, so it has to be coming out, and some pattern has to be created when we're looking at those unsupervised learning, right? And the third one is what we call a hybrid with semi-supervised learning. In that case, you do have some data, but the majority part of the output, you don't have that data, right? So you're looking, it's a combination of supervised and unsupervised learning. And last but not the least, we have what we call the reinforcement learning, and that's more of a trial and error, right? Whereby you are looking at experience, you are looking at different environments, and the environments are dynamic, and how does your learning model changes based on those environments, right? So those are the 4 key areas from the training methods in AI ML that the industry is looking at. All right. High level, again, I'm not going to go over the picture of how the ORAN architecture looks like. I think it's pretty well covered. The key area I wanted to focus on were the different basically control loops that have been defined, right? So there are some non-real-time loops that are being decided within the non-real-time RIC. Again, that is certainly looking at things that are on the order of 1 second or higher, and then you have 10 millisecond to 1 second, which is happening in the near real-time loop. And then you have stuff that is less than a millisecond, say if you want to do optimization and make changes at symbol level. So something that like changing something at switching a cell on and off, doing some traffic steering, that is going to be coming in the non-real-time loop. It's more considered a supervised learning, right? It can be done, but it should be done basically at with a longer time delay. It doesn't require real-time expertise over there. So those are some of the 3 different action loops that have been created, and you can see it on the left side what the different loops timings are over here. So moving on, again, this is taken from one of the 3GPP, ORAN document. It talks about what is the flow of, say, supervised learning when you are switching off a cell, right? Or if you want to steer a traffic for some reason. And the different deployment options, this is one of the deployment options. This deployment option is basically your data collection is residing in your non-real-time RIC. There is an option whereby you could have some of this inference model that are going to be built into the real-time RIC. So in this case, you're basically sending the messages down, activating energy saving to the basically your nodes. nodes could be your DU, for instance, and then that forwards it over to your RU. Now, the key thing over here to see is the RU compliant? Is the RU able to provide you all the information that is required to read the energy consumption information, right? It's an assumption because the DU could be separate, the RU could be different. Obviously, you have your RIC over there as well, but is the message that you can send to the DU that's going to be forwarded over the RU to over the front haul, does the RU comply with that, right? So again, Open RAN is great, no doubt about it, but again, this has to be properly tested to make sure that those messages are being able to be receptive by the RU. And again, all that information is going back, collected, as well as inference model has to be built up by in the real time, in the non-real-time RIC or the real-time RIC, depending on what the deployment options are. So these modeling has to be done continuously. And as this goes on continuously, then you create an algorithm whereby you can decide when to switch off a cell, switch on a cell, or basically switch off a channel for that matter, and switch on a channel, right? So again, this is high level, but the key area over here is now we're developing these AI ML models. How do we test them? That is where the quick question comes, because we have input A, we have input B for supervised learning. We already provide the input, but the things are changing, right? Now we develop an algorithm. How well will that algorithm adapt to the changing environment, right? Does the algorithm actually give us A equal to B, or it's going to give us A equal to C? So there could be some deviation also that can happen over time. So that has to be also properly tested. So there are some certain aspects that have been developed and are being looked at from what are the test tools for AI and ML. And there are 2 aspects to it. One of them is how do we incorporate AI ML into test tools to make our test tools smarter? But the key question is how do we test an AI ML algorithm, right? You would have an AI ML algorithm that may be residing in one component of your network, which is your radio access network, or one feature. But then to test it in totality, that's a key challenge, right? So there the different frameworks that have been defined on how do you make those testing methodology. One of them is looking at one-sided model, whereby you are testing it in isolation. And the other part is you have the test equipment replicate the other side of the model. So basically you could have a UE and you could have a radio access network. And that way you're measuring the different model, whatever the performance of the algorithms that have been developed as a result of the data collection activity that I talked about in the previous slide. All right, so again, it's very key that we have the right KPIs to measure AI/ML, even from an energy efficiency perspective. The key thing is first, have the right KPIs to measure energy efficiency. Second part is now when we introduce AI/ML, are those algorithms performing as needed, right? Because think about it, right? You want to make sure if you're switching off cells, those cells are switched off after all the data that they were supposed to process have been processed. If you're doing any kind of traffic steering, we don't want to be doing that in the middle of a session that's going on between a device and the network. So that also has to be properly calibrated. Right, so last but not the least, from a summary perspective, energy efficiency is very, very key, right? It's pivotal. As I said, as we go into 6G, this may be something mandated, right? The radio access network vendor should be able to provide the operator, these are my numbers, in isolation of each component, and now it is end-to-end solution, because you have to measure RAN or energy consumption, when there is no activity or when there is activity, when there is build out happening, as well as when the system has been deployed and the network is running, what is the energy efficiency in that case, right? So that's one of them. The other part is basically, as I said, we want to make sure that the AI/ML algorithm that has been developed is not having any adverse effect. So it has to be properly tested. That is very, very key. Make sure the process that was being run before a cell switch, before a handover, before a switching off any kind of antenna arrays, then it's no process happening at that time, right? And then measuring and doing it continuously is also very, very key component, right? So because your algorithm can only be as good as the data you have collected. So garbage in, garbage out. So let's make sure that we're able to collect the data across the different environments, across wide time. We have a lot of sample data. So we develop the right algorithms and we can implement them in energy efficiency manners, right? Last but not the least, we look at, virtualization, we have Open RAN, we have cloud natives. So that's very important that, we look at all those assets and be able to track and optimize the energy efficiency end to end, right? That's the key part, not just focusing on a certain function. We start with that, but we also look at it, what is end to end. So that should bring me to the end of my conversation. These are some references that you can do reading during bedtime stories or so, but that should be good stuff, but that should bring it into any questions, comments?
We have, thank you for sticking to the time. We probably have time to have 1 or 2 questions. Anybody from the audience or from online? So I have a question. This is very important topic, right? I think what you're doing. Within IEEE Future Networks, we have an energy efficiency working group. I was thinking some of your findings could be potentially useful there.
Sure.
We produce something, we call it roadmap, like 3-year, 5-year, 10-year from now, how things are going to look like. So I'm going to introduce you to the co-chair, Brian, of Energy Efficiency Working Group, and see we can maybe potentially contribute there.
Sure,
well.
absolutely. That's certainly very helpful because we all have to work together. It's something new that has not really been mandated, but to create the KPIs is very key, and KPIs that make sense.
Right. I know in NextG Alliance, they have something called sustainability,
Yes. Yes.
I mean, there are multiple efforts going on.
Yeah.
So this is good.
Sure. Thanks very much.
Right. So I'd like to thank you again, and token of appreciation. Sahez, if you'd like to take a picture for Adnan. So I'll request Purva to, you can open the certificate. So maybe you can just stand here in front of that. So go there, actually, we can just, So is everything's coming? I just want to, all right. So at this time, we should move to the break. I know we are running late, maybe about 20 minutes. So let's take about 15 minutes break. This is for the folks who are online, just a certificate appreciation for Adnan for giving a wonderful talk. So we'll just take about 15 minutes break. We'll be back after that, and there'll be more on-site speakers. Thank you. And folks online, I may just want to take a stretch break, go for a coffee or tea or whatever.